Several factors could explain why the dog did not experience severe consequences from chewing on the exposed 240 volts wires. Firstly, the current flow is a key factor. Even though the circuit was rated for 20 amps, it is improbable that the dog was subjected to the full 20 amps. The dog's inherent body resistance, combined with the limited surface area of contact between its mouth and the wires, likely restricted the amount of current that could pass through its body. This reduced current flow could have been below the threshold needed to cause significant harm. Secondly, the duration of contact plays a crucial role. The information suggests the dog's chewing on the wires was not sustained for an extended period. Had the contact been prolonged, the animal would have been exposed to a more substantial shock, potentially leading to more severe outcomes. Thirdly, environmental conditions such as dryness can influence electrical conductivity. The presence of carpet on the floor might have provided some degree of insulation, thus diminishing the amount of current that traversed the dog's body. Dry carpet acts as a poor conductor of electricity, increasing resistance and decreasing the likelihood of a strong electrical pathway through the animal. Fourthly, a dog's physiology is relevant. Dogs tend to possess a naturally high body resistance compared to humans, which serves to limit the current flow when exposed to electrical sources. This higher resistance acts as a protective mechanism, reducing the severity of electric shock. Addressing the loose ground wire mentioned, it is unlikely this played a significant role in the dog's survival. The primary function of a ground wire is to offer a secure route for excess current to dissipate in the event of a short circuit. In the scenario described, there was no short circuit present, thereby negating the ground wire's protective function. The absence of a proper ground could increase risk in other electrical fault situations, but not necessarily in the case of the dog chewing the wires. Even with the factors mentioned, it is crucial to emphasize that handling live wires is exceptionally dangerous and should never be taken lightly. Always disconnect power to the circuit at the breaker before undertaking any electrical work or repairs. Safety precautions are essential to prevent electrical shock and injury. A 20 amp circuit at 240 volts, under the right conditions, can be lethal to humans and animals. Electricity follows the path of least resistance, and if that path happens to be through a living being, the consequences can be devastating. The effect of electric shock can vary significantly depending on several factors. These include the voltage and amperage of the current, the duration of contact, the pathway the current takes through the body, and the individual's overall health. In general, higher voltages and amperages pose a greater risk of serious injury or death. The duration of contact is also critical, as prolonged exposure increases the likelihood of tissue damage and cardiac arrest. The pathway of the current through the body determines which organs and systems are affected. If the current passes through the heart or brain, the consequences can be particularly severe. Individual factors, such as age, health status, and pre-existing conditions, can also influence the outcome of an electric shock. Children and individuals with heart problems may be more vulnerable to the effects of electricity. Electrical safety devices, such as ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock. A GFCI monitors the current flowing in a circuit and quickly cuts off power if it detects a leakage current, which could indicate a ground fault. GFCIs are commonly installed in bathrooms, kitchens, and outdoor areas, where there is a higher risk of water exposure. Regular testing of GFCIs is recommended to ensure they are functioning properly. Electrical codes, such as the National Electrical Code, or NEC, provide detailed guidelines for safe electrical installations. These codes cover a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Adherence to electrical codes is essential to prevent electrical hazards and ensure the safety of people and property. Proper grounding is a critical aspect of electrical safety. Grounding provides a low-resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. A properly grounded electrical system helps to prevent electric shock and minimize the risk of fire. Electrical panels should be clearly labeled to indicate the circuits they control. This makes it easier to identify and energize the correct circuit when performing electrical work. Circuit breakers and fuses should be sized appropriately for the circuits they protect. Oversized breakers or fuses can allow excessive current to flow, leading to overheating and potential fire hazards. Regular inspection and maintenance of electrical systems are essential to identify and correct potential problems before they become serious. This includes checking for loose connections, damaged wiring, and malfunctioning equipment. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. Electricians have the training and experience necessary to safely and correctly install and repair electrical systems. They also have the tools and equipment needed to perform the work properly. When working with electricity, it is important to use the correct tools and equipment. This includes insulated screwdrivers, pliers, and wire strippers. Never use tools that are damaged or have frayed insulation. Always wear appropriate personal protective equipment, or PPE, when working with electricity. This includes safety glasses, gloves, and shoes. Avoid working in wet or damp conditions, as water can conduct electricity and increase the risk of electric shock. Before working on any electrical circuit, always turn off the power at the breaker panel. Verify that the power is off by using a voltage tester. Never assume that a circuit is energized simply because the switch is turned off. Be aware of the potential hazards associated with overhead power lines. Maintain a safe distance from power lines when working with ladders, scaffolds, or other equipment. If you come into contact with a down power line, stay in your vehicle or on the ground and call for help. Never attempt to move a downed power line yourself. Educate children about the dangers of electricity and teach them to stay away from electrical equipment. Cover unused electrical outlets with safety caps to prevent children from inserting objects into them. Store electrical cords and cables out of reach of children and pets. Avoid overloading electrical outlets and extension cords. Overloading can cause overheating and potentially lead to a fire. Use power strips with built-in surge protectors to protect electronic equipment from voltage spikes. Unplug electronic devices when they are not in use to save energy and reduce the risk of electrical hazards. Dispose of old or damaged electrical cords and equipment properly. Do not throw them in the trash, as they can pose a safety hazard. Recycle them whenever possible. Stay informed about electrical safety by reading articles, watching videos, and attending training courses. Knowledge is the best defense against electrical hazards. Remember that electricity is a powerful force that should be treated with respect. By following safe practices and taking precautions, you can minimize the risk of electrical shock and fire. It is important to note that even though the dog may have survived this incident, it does not mean that future encounters with electricity will be harmless. The severity of an electric shock can vary depending on numerous factors, and it is always best to err on the side of caution. Keep pets away from electrical wires and outlets, and take steps to ensure that your home is electrically safe. If you have any concerns about electrical safety, consult with a qualified electrician. They can assess your home's electrical system and make recommendations for improvements. Electrical safety is a shared responsibility. By working together, we can create a safer environment for ourselves, our families, and our pets. Remember, when in doubt, always turn off the power. And never hesitate to call a professional if you are unsure about how to proceed with an electrical task. Your safety is worth it.